Today we're going to talk about two rules of integration. Now the first rule is that if I have a constant in front of what I want to integrate, this does not affect the integration. So the integral of 4x to the 7 with respect to x is the same as 4 times the integral of x to the 7 dx. So when I'm integrating this, I'm going to keep the 4 where it is because it's not affected by the integration process. The x, I'm going to increase the power by 1 and then divide by the new power, and remember my constant of integration. Now at this point, the 4 does come in because I'm going to be able to cancel these out and be left with x to the power of 8 over 2 plus c. So that's the first rule. If there is a coefficient in front of the x term, it's unaffected and it's still there after we integrate. Remember, when we've got the symbol here, it means we've yet to integrate. When the symbol disappears, we know that we have integrated. And of course now we see our plus c. The second rule that we're going to look at is that when I integrate a number of different things, it's the same as integrating each of them separately. So that's the same as 7 times the integral of x squared plus 4 times the integral of x squared minus 6 times the integral of x. And I can simply integrate each one. So 7 times raise the power by 1 divided by the new power, plus 4 times raise the power by 1 divided by the new power, minus 6 times. Now be a little careful here, because remember, when there's no power, the power is actually 1. So if we're raising that power, it's going to be x squared over 2, and I need my constant of integration. Because the first two terms are both over 3, and I've got 7x cubed plus 4x cubed, that's 11x cubed over 3, minus, and then I've got 6x squared over 2, so that's the same as 3x squared plus c. Now within this example we saw that when we integrate x, it becomes x squared over 2, and that's the one of ones we have to be a little bit careful of. Additionally, if we integrate a constant term, we need to remember, so the x is x squared over 2. The 3 that's there is a bit like having x to the power of 0, because remember that's 1. So when I raise that power by 1, I'm actually going to end up with 3x, and it's to the power of 1, which we don't need to write, divided by 1, which I don't really need to write, plus c. So it's x squared over 2 plus 3x plus c. Okay, we're going to page 2 in our notes, and the first example that we're going to do is 6x cubed. And remember, that's the same as 6 times the integral of x cubed, which is 6 times, well, the x I'm going to increase the power by 1, I'm going to divide by the new power, and I'm going to add the constant of integration. I'm going to do a little bit of cancelling there. So I'm going to end up with 3x to the 4 over 2 plus c. Don't forget your plus c. Second example is 4x to the negative 3 over 2. And this is the same as 4 times the integral of x to the power of negative 3 over 2, which is 4 times, I'm increasing the power by 1, so negative 3 halves plus 2 halves will give me negative a half. I'm dividing by the new power, so I'm dividing by negative a half. Ooh, that looks horrible. Plus c. Don't worry about it at this stage. If it looks ugly, we're putting it right in. We're going to sort that out in a second. Dividing by a half, remember, is the same as multiplying by 2. So the whole fraction is going to be negative because it's a positive divided by a negative. So I'm going to just put the negative here. And instead of 4, I'm going to have 8 because I'm multiplying by 2. The x is to the power of negative a half. So to make that positive, I'm going to pop it underneath the fraction, and the half is a square root. So it's going to be negative 8 over the square root of x plus c. Okay, we're moving on to page 3. We're ignoring examples 6 and 7 for the moment and going straight on to 8. Now here we're asked to find the integral of 3x squared minus 2x to the power of a half. Now the brackets are just there because this whole function is with respect to x. So all of this is corresponding to the dx. And remember, this is the same as the separate integrals. So it's the same as 3 times the integral of x squared minus 2 times the integral of x to the power of a half. X squared becomes x to the power of 3 divided by 3 minus 2 times x to the power of, adding 1 to half gives me 3 over 2. Dividing by 3 over 2, we'll sort that fraction out in a minute, plus c. On the first fraction here, I've got 3x cubed divided by 3, so that's just x cubed. Dividing by 3 halves is the same as multiplying by 2/3, so it's going to be negative 4 over 3. The x is positive, so it's staying on the top, and it's the square root of x cubed and plus c. And our final example today, we are integrating 4x to the power of negative 5/8 plus 3x plus 7, and that's all with respect to x. I'm not going to separate them out. I'm not writing them out separately, but I am in my mind separating them as I integrate. So it's going to be 4 times x, I'm increasing the power by 1, so negative 5/8 plus 8/8 will give me 3/8, and I'm going to divide by that 3/8, plus 3 times, that's x to the power of 1, so it's going to be x squared over 2, plus 7 is x to the 0, so it becomes 7x, plus my constant of integration. Dividing by 3/8 is the same as multiplying by 8/3, so 8 times 4 is 32. It's over 3, the x is positive, so it's staying on the top, but it's 8th root of x cubed, plus 3x squared over 2, plus 7x, plus c. To check your understanding today, I'd just like you to try to integrate this expression here. We're now in a position to try the examples in exercise 9H, and I recommend that you do these in class with me.